In this simulation, we have a picture that represents the velocity of a projectile that is launched at some angle. We have the angle set at 45 degrees and we have the initial speed of launch set at 50 degrees. And once we hit play, we can see the velocity vector, which is the longer vector here, the blue one, along with the components of the velocity vector. And so there is a component of that velocity vector along the horizontal and a component along the vertical. So let's go ahead and hit play. And we notice that during the motion, the horizontal component of the velocity stays the same throughout the motion. So the horizontal piece is always the same length. It never changes, which means that the velocity along the horizontal stays constant. I'm going to reset it and we're going to look at the motion on the way up. So we're going to focus on the vertical component of the velocity, and I'm going to hit play. And I notice that on the way up, the vertical velocity decreases. So as the object is traveling upward, the vertical velocity is going to decrease on the way up. But when it gets to the very top up here, where it's about ready to turn around and come back down, the vertical velocity is 0 for an instant in time. And then as it falls back down, let's reset it one more time and hit play. So it reaches the top where it has 0, and then it starts to come back down. And as it's coming back down, that vertical velocity vector is increasing. So it's getting larger and larger over time. So on the way up, the vertical velocity decreases. At the top, the vertical velocity is 0. And on the way back down, the vertical velocity increases. At the very top of the trajectory, the velocity has its smallest value. So the line itself here, that blue line, is the smallest. That's a little harder to see, but let's go ahead and hit play. So it's the smallest, and then it increases as it's coming back down. And the reason for that is because the velocity is a combination of the horizontal velocity and the vertical velocity. Since the horizontal velocity always stays the same, but the vertical velocity is the smallest at the top, that means that the minimum speed of this projectile is at the top. At the top, though, the velocity is not 0 because this projectile still always has horizontal speed associated with it.